Hello everybody, this is Mrs. Wild from your WCA physics class. And what I really wanted to show you today was what to do for your kinematics portfolio. We are going to be using the worksheet that's in the lesson, and you're pretty much doing the portfolio as is in the lesson, but I just wanted to explain how to do it for you. So in this portfolio, you're actually going to be setting up a ramp at home so that you can let a ball roll down the ramp and you can measure how far that ball lands away from the ramp. You're going to first calculate how far you think it's going to go. So you're essentially comparing your calculations to what actually happens. So you're doing like a calculated distance and comparing it to an actual distance, and then you're going to look at how much error is between the two. So let's kind of go through the experiment first, experimental setup. You need some type of rolling object like a ball, golf ball, something small is preferable, a little ramp you're going to make, and you're essentially going to set it up like this, okay? So that you have a tabletop, this is your ramp, maybe it's a little piece of cardboard or wood or something that you prop up on some books, and you're going to roll that down the ramp. You also need to have it some distance away from the edge of the table. So if you can see here, this is the edge of your ramp and this is the edge of your table. And then once it falls off the table, it has an initial velocity equal to v sub I. It's going to follow this parabolic pathway and land some distance away, capital D, from the edge of the table. The height of the table here is represented by a capital H. Again, in my brain, this should be X and Y, but that's not how they've done it or set it up here. Okay, so you're going to make your setup, and they would like you to draw a diagram of your setup here. You can use some of the tools that are available for draw right in the Word program, or if you would like to just draw it on a piece of paper and take a picture of it and then send it to your computer as like a PDF or a JPEG or something and insert that picture here, that would work as well. You want to leave some space from the edge of the ramp to the edge of the table, and it should be between 50 and 100 centimeters. And remember that we want to measure this in metric, and I would actually measure it in meters rather than centimeters. So like 50 centimeters would be 0.5 meters, and 100 centimeters would be, I'm sorry, 50 centimeters would be 0.05 meters, and 100 centimeters would be 0.10 meters, so that you have consistent units throughout. And then you're going to practice kind of releasing the ball from the top of the ramp and letting it roll down. And what you want to gather is the time from when it leaves the end of the ramp to where it leaves the end of the table. So you're going to need a stopwatch. And as soon as it hits the end of the ramp, this point here where my cursor is, you're going to start the timer. And then once it gets to the edge of the table, you're going to stop the timer. And you're going to do that 3 times. And that's where you're going to put down here for your trial in seconds, and then you'll get an average time in seconds as well. Then you need to determine the horizontal velocity, v sub naught, or this is the velocity when it leaves the table. Because remember from our practice problems, the horizontal velocity will be the same as the velocity of the ball when it hits the floor in the x direction. It has the same horizontal or initial velocity horizontally as it does final velocity horizontally. So they gave you an example here. If the time was 4 seconds, you are going to measure the distance in meters. Again, that's the distance from the edge of the ramp to the edge of the table, which was between 50 and 100 centimeters, but we want to use meters. And then divide it by the time, and that gives you the velocity in meters per second. And then you can come up with the average velocity here, okay? Again, average, you take the total numbers and divide by the number of trials, which is 3. Then we get our average velocity v sub naught here, right? Okay, this is where it gets a little bit trickier, but I want to make sure that you understand. So we're using some of the kinematics here. If you remember, we can use kinematics in the x direction or the y direction. It really doesn't matter which direction, but we have to take into consideration both of those dimensions. You can't just use one or the other. So this ball is rolling off the edge of the table, and we can determine how far it falls, which is D, capital D here. which again, a lot of times in those kinematics in your lessons is going to be x, but that's this distance, horizontal distance. So we can use one of the kinematics to determine that. That's the first one right here. So d is equal to v sub naught times delta t times 1/2 a delta t squared. But because we know the initial velocity in the x direction is the same as the final velocity in the x direction, we know there's no acceleration. So this part, the right part of this equation, we don't need to use because a will be 0. So just get rid of that, and we know then that the only formula we need to use to calculate the distance that it falls away from the table is its initial velocity times the change in time. And you might be thinking, I have time. I use my stopwatch. You can't use that time. That is just your measured time. We need a calculated time because we're trying to determine whether calculated is going to be the same as measured. So we're going to be using the y direction, the height of the table, to help us determine that. So in the y direction, we would say y, or in this case h, the height of the table, is equal to v sub naught delta t plus 1/2 a delta t squared. We know what a sub y is here. That's negative 9.8 meters per second squared. We also know the height of, sorry, we knew that, I was going to say, we know the height of the table in meters. You have to measure that with your meter stick. That's a measured quantity. And in this case, also, let's see here. We do not need to use this first part, this v sub naught delta t, because it has no initial vertical velocity. It's dropping. So it starts off with a v sub naught in the vertical direction of 0. So it just becomes 1/2 a delta t squared is the only part of the formula that you actually need. So this part here, as you can see, that first chunk is just 0. So it's 1/2 a, which is negative 9.8, delta t squared. And again, you're measuring the height. And so that's where we get this formula here. So you'll be able to just plug this in. The height of the table is equal to negative 4.9 times delta t squared. And so you'll be able to take and solve this for t. And you're going to put that calculation here. And you're going to do that again for you know, we're just looking at like a one-time calculation here. So you need to depend on how high your table is and how high your counter is. Your H will be different from your friend's H, right? Once we get that, then that gives us T. Once we're able to, measure our height and solve for delta T, we can then plug delta T back into our original formula. We know that the initial velocity, we've calculated that. We also will know delta t, and that will allow us to solve for d, the horizontal distance. And I want you to do that calculation here where you're solving for d. Show me the money or show me the work here, okay? Then you're actually going to have to compare. So for each one of these ranges, okay, you're going to measure how far did it actually go. Okay, this is where it might be helpful when you let the ball go, okay, and it falls off and falls onto the floor. I've suggested maybe putting a piece of cardboard on the floor and then lightly dusting it with like flour or cornstarch or something, because then when the ball falls, it'll make a mark. And you can measure the distance from the edge of the countertop to that mark. And you're going to do that 3 times to get the range of the projectile. So you're going to actually do this. You're going to measure the distance here, okay? Go straight down from the countertop to where you hit the floor and make a mark. And then wherever that ball lands, that's your D. You're doing that 3 trials. And you're going to see how close is that trial, that range, to my calculated D, which I did up here on page 6. So then you just have some questions to answer. You're going to ask like, how close is it to your range? If they're very, very different, check your math. How precise were your measurements? We're reflecting here on sources of error. Sometimes this is where our sources of error come into play. And how accurate do you think the measurements were? So that's the extent of what you need to do. It looks complicated on the worksheet, but in reality, it's really not that complicated at all. Hopefully the video kind of helps a little bit with your understanding of how to do those calculations. If not, if you're still stuck on some of these, please see me for additional help. And thanks for tuning in. Bye, everyone.